5.4 goes over the values of the 6 trig functions, and your essential question is how do you find values of the six trig functions approximately, by calculator, exactly, and for special angles. Not much is new here, but it's a good review for you. So we're going to start by putting an angle in standard position in the first quadrant. That way we have something to reference. So here's some ray, and this ray is opening, okay, and we have to remember that it could include all 4 quadrants, in which case this angle could open up to any one of the 4 quadrants. But either way, we're always going to look at the reference angle. So you always want to think about that reference triangle, right, that right angle there by drawing from the ray down to the x-axis, getting that right angle, which creates this right triangle. And your angle that we're talking about here is theta. So we end up with this like radius, which is our ray. We end up with an adjacent leg, which is also our horizontal coordinate, or in your textbook they let that be u. You might also think of this as the x-axis. That's totally fine. The radius is thought of as the hypotenuse. This vertical line that we draw down to the horizontal axis is thought of as the opposite leg. Or they're calling that the V, that height is V. So they're calling this the U axis and the V axis. And I'll use those interchangeably. Sometimes I'll call this the x-axis and the y-axis. And this point right here on the ray is going to be some point UV, right? It's going to have the same horizontal length as the adjacent leg and the same vertical measurement as the opposite leg. All right, so in the past, you have learned about several trig functions, the first one being sine of theta, and we always said that that was going to be the opposite leg over the hypotenuse. You've also learned about cosine theta, and we've always said that that was going to be adjacent over hypotenuse. And then you also learned about tangent. And your textbook does a good job of explaining why tangent and secant have their names. Let's see, where did I see that? Page 263, if you're curious, you can go ahead and read about that. That was interesting information. So tangent has always been opposite over adjacent. And maybe in the past you've learned a little sine. So, oh, I should write that with lowercase. So sine would be opposite over hypotenuse, cosine would be adjacent over hypotenuse, and tangent would be opposite over adjacent. So SOHCAHTOA gives you a little memorization acronym there. We've also got the reciprocals of these guys. So the reciprocal of sine theta is cosecant theta, in which case you've got the hypotenuse over the opposite. The reciprocal of cosine was secant theta, in which case you got the hypotenuse over adjacent. And the reciprocal of tan theta is cotan theta, or cotangent theta, in which case you've got adjacent over opposite. So this was all when you learned how to do this using right triangles. And again, when I do this in a coordinate plane, I'm always drawing a right triangle anyway, so I am using a right triangle. However, in your textbook, they also just talk about in coordinate form. You know, so when you're thinking about sine, this could really be the vertical coordinate over the radius. And they use V for vertical and then R for radius. And then the reciprocal of that would be, well, the reciprocal of that, oops, not that. It'd be R over V. All right, so for cosine, they use, instead of adjacent, you can think of it as the horizontal coordinate over radius. I better not put, I'll put radius. which they're using the u for the horizontal coordinate. And again, most of the time we want to work with a radius of 1. We want to be thinking about that unit circle, but that's not always going to work out for us, okay? So sometimes we are going to really have to think about, how long do I want this radius to be, or this hypotenuse? And really that'll be dependent on the circle that's out there. If we're using the unit circle, then it's got a radius of 1. If we're using a different circle, it doesn't have a radius of 1. Hypotenuse over adjacent, well, that's just the reciprocal of basically adjacent over hypotenuse, so we're just going to use r over u, the radius over the horizontal coordinate. And then for tangent, you're going to be using the vertical coordinate over the horizontal coordinate. Or in other words, v over u. And then the reciprocal for cotangent would be u over v. You already know this stuff, the opposite, the stuff dealing with the right triangles. That's really where you should be focused, okay? And just draw a bunch of right triangles, and that'll really help you. But just to coordinate with your textbook and with, learning something new, I wanted to also introduce you to this other coordinate notation. Okay, so let's talk about one more thing before we start doing some examples. How about your special right triangles? Let's just review these. I'm sure you all know them by heart. So one of them is a 30, 60, 90. And the other one is a 45, 45, 90. So in the 30, 60, 90, we're going to have the side across from the 30 degree be A. The side across from the 60 degree is bigger than this side, so it's going to be A root 3. And then that leaves your hypotenuse to be 2A. And then in the 45, 45, 90, you have two congruent sides, because this is an isosceles triangle. And that leaves your hypotenuse to be A root 2. Okay, so depending on what side you're given, and we did this in geometry, and we did it again in Algebra 2, but depending on what side you're given, you can always set up an equation to figure out what the other sides are. And we'll practice with that a little too. Okay, I think we've reviewed everything we need, and now we're just going to go through and do some examples. I'm going to do the examples right out of your book. So example 1, this comes from page 264. You're going to need your calculator for this. We're going to evaluate by calculator the 6 trig functions. So let's see, it's 58.6 degrees. By calculator using the 6 trig functions. And we're going to round to 4 decimal places. All right, let me find my calculator here. So again, you want to make sure that you are in the correct mode. So you don't want to be in radians just yet. We're going to be working with degrees, especially because we were given our original here in degrees. Okay, and I'll just do a couple of these, and then I think you'll get the idea, so I don't have to do all of these and waste your time. So let's start with, how about sine of 58.6? Let's write this down. Let's keep good track of what we've got here. Oops. So sine of 58.6 is going to equal 0.8536. Oh, I should say approximately, because it's not exactly. So it keeps going. Let's also do the reciprocal of that. So we'll do cosecant of 58.6. I should write degrees. Okay, so that's the reciprocal of sine. So let's all look on our calculators here. Does anybody see cosecant here? We don't see cosecant. So there's not a cosecant button. So it's important that you realize that cosecant is the reciprocal of sine. Okay, so cosecant of 58.6 is really going to be the same thing as 1 over sine of 58.6 degrees. So I'm just going to find 1 divided by sine of 58.6. And that's going to give me approximately 1.1716. Okay, and so cosine, well, the reciprocal of that's going to be secant, right? And then for tangent, the reciprocal of that's going to be cotangent. So that's how you're going to calculate those using your calculators. Okay, let's move on to example 2. So it's important that you know that you can always estimate these using a calculator, but there's also ways to find the exact angle using geometry. So you can find the exact angle. You can find the exact values of the trig functions if you know a point on the terminal side of the angle. Okay, so let's do example 2. Okay, so we know that the terminal side of angle theta contains -5, 2. Find exact values of the 6 trig functions. Oops, sorry, I was off the page there. So the first thing you want to do is you want to sketch this angle in standard position. Okay, so if I'm talking about -5, 2, then I know I'm over here somewhere. So this point was -5, 2. All right, then I know that this side is 2. I know that this side is 5. So it's going to be important that I also figure out what my hypotenuse of this right triangle is that I've just drawn in. Okay, my angle theta is actually here. But remember, I'm also going to have this reference angle right here that I'm going to be thinking about. Okay, and I'm also going to think about which quadrant I'm in. I end up being in quadrant 2, right? So really, even though I've labeled this as a length of 5, I'm really -5, right? I'm in the -5 direction. All right, so finding my hypotenuse, let's figure that out first. So 5 squared plus 2 squared equals my hypotenuse squared. So 29 equals my hypotenuse squared. So my hypotenuse is the square root of 29. Okay, so sine of theta. Okay, so really I'm using this reference angle right here. Okay, and that's in this right triangle. Okay, so you can think about this as your reference angle. So sine of my reference angle really is going to be, let's see, opposite over hypotenuse. Opposite is 2 over my hypotenuse is root 29. Or vertical coordinate over my radius, okay? So right away I should know then that cosecant of theta is going to be my reciprocal of that, root 29 over 2. Nobody has specified the fact that we have a radical in our denominator. You could rationalize that, but I would rationalize it after you've done the reciprocal functions, okay? After you've, done this, otherwise you're going to have to rationalize the denominator again. All right, so let's just do, how about we do tangent as well? I'll just do one more with its, so tan theta, okay, so looking back at my triangle, it's going to be opposite over adjacent. So then cotan theta is really simple. It's just going to be the reciprocal of that, 5 over 2, okay, or adjacent over opposite. Oh, and we have a problem because I didn't use a negative, did I? So tan theta, well, that's great. I'm in the second quadrant, so I need to remember that this is a negative value as far as my horizontal distance goes, right? So my horizontal distance is actually negative, which makes both of these negative. Okay, moving on. I'm imagining you can do cosine of theta and secant theta. I think you'd be able to do that on your own. Let's move on to example 3. So this will bring in some of our special right triangles. All right, so example 3 asks us to find the exact values of 6 trig functions of 300 degrees with u equaling 1. So u is going to be our horizontal coordinate. So we'll keep that in mind when I draw my reference triangle. So I'm going to draw this on a coordinate plane. We're talking about 300 degrees, so I end up in the 4th quadrant. Let's say around there. So this right here is 300 degrees, making my reference angle 60 degrees. Now u is 1, so that means that this whole horizontal piece is going to be 1. And I drew this so it would be a right triangle. So I've got a 30, 60, 90 triangle. So my smallest side is going to be A. So I know that 1 is the same as A. And then I get a hypotenuse of 2A, which is going to be 2 times 1. And then I get the longer side being A root 3. So basically this is just root 3. So now I can go through and I can find all of the different 6 trig functions. So sine of theta is going to be opposite over hypotenuse, which is root 3 over 2. Cosine of theta is going to be adjacent over hypotenuse, so that's going to be 1 over 2. And then tan of theta is going to be, let's see, so opposite over adjacent, so root 3 over 1, or just root 3. And then I can go through and I can do the reciprocals of these. So cosecant theta is going to be 2 over root 3. Secant theta will be 2. And then cotan theta will be 1 over root 3. Let's do one more example. So you're not going to use a calculator. We're going to evaluate the 6 trig functions for an angle of 180 degrees. So I'm just going to write no calc. Evaluate 6 trig functions for 180 degrees. So thinking about where 180 degrees falls, right? So we're basically on the x-axis, okay? And you can just pick any point on here. I'm going to use the unit circle. So let's just say that here I end up at -1, 0. All right, so starting with sine of theta, or sine of 180 degrees would probably be a better way that I could write this. And I could have done that up here too. I should have done sine of 300 degrees. So let me go back and fix that. When you know the actual angle, you should put it in. Okay, so sine of 180 degrees. A couple ways you can think about this, and one of them is thinking about your unit circle. And if I'm at 180 degrees, well, I know that that's going to be -1, 0 on my unit circle, and therefore I know that the sine is actually going to be 0. But using component form, well, component form is for sine is the vertical component over the radius of the circle. Okay, well, the vertical component, I'm not up at all off of the x-axis, so my vertical component is 0. And then my radius of this, if I think about how far it is, it's 1. Okay, so I end up with 0. So we get the same answer either way. Let's think about cosine of 180 degrees. So again, cosine here, I know it's going to be -1. But it's also the horizontal component over the radius. Well, the horizontal component is -1, and the radius of the circle would be 1. So we're going to end up with -1. Tangent of 180 degrees, well, that's going to be opposite over adjacent. Okay, or in other words, that's going to be, let's see, opposite would be your vertical component over adjacent would be your horizontal. Okay, so my vertical component, once again, is 0. My horizontal component is -1. That gives me a 0. And now it should be really easy for me to figure out the reciprocals of these. So starting with cosecant of 180 degrees, the reciprocal of that is going to be 1 over 0. Okay, so we got a problem there. It's undefined. Secant of 180 degrees would be the reciprocal of cosine of 180 degrees. So 1 divided by -1 is still -1. And then cotan of 180 degrees. Once again, if I take the reciprocal of this, it becomes undefined.